So Kristen is a research agronomist at the University of Manitoba. She focuses on soybean, dry bean, and pea production practices for Manitoba cropping systems. She also teaches courses in crop production and stays connected to farmers and agronomists through extension, many of whom she met in her previous role with the Manitoba Pulse and Soybean Growers, where I know her from. Kristen obtained her agriculture diploma, Bachelor of Science, and Master's of Science from the University of Manitoba, and recently entered a PhD program. Outside of research and education, Kristen keeps her boots on the ground, raising crops, cattle, and 3 adorable children, along with some sourdough starter, with her husband on their family farm. And with that, I'll turn it over to Kristen.
Okay, thanks, Tammy. I didn't think I had the sourdough part in there, but that must have been from last night. Okay, good morning, everybody. So I have to admit that I kind of feel like the new kid on the block here, talking about soybean yield potential amongst our speakers working on wheat and our next speaker on canola, considering that it's really just been the past decade that soybeans have come to Manitoba, and many of you as agronomists have been working on the crop. And just as a little bit more background, so we started growing soybeans on our farm in 2012. I started my career in soybeans as well in 2013 with Manitoba Pulse and Soybean Growers, and my role there was really to learn quickly how to grow soybeans, bring information in from other regions, extend it to farmers, extend it to agronomists. Then we quickly realized that we had a lot of research to do, a lot of production questions to answer. And then that also brought me back to the U of M to increase that capacity and support other colleagues who were doing more research investment in the area of soybean production. And when John and Dennis asked me to talk about soybean yield potential, I'm like, yes, this is definitely something that we've been thinking about in the last few years. We've had bumper crops, which I'll tell you a little bit more about. And as I was preparing for this, I was reflecting in my office, and I have some memorabilia. Who remembers Manitoba Agronomist Conference when they had the printed coiled book? So this one's from 2013. It was my first MAC. And I just find it ironic that I was looking at the topics, and it was corn and soybeans come to Manitoba. Heat unit risk for corn and soybeans. And then through the years, it's been how to manage white mold, how to manage aphids, these new pests. And then just a few years ago, Dennis was talking about, are we going to hit 3 million acres? The evolution of soybean production. And so here we are now, over a decade in the making, and we're going to explore what soybean yield potential has become, what it looks like, just kind of a characterization of it, maybe for the first time. So let's get started. And I also have to thank Brian and Joachim for also introducing and defining these things for me. It's going to save me some time. Maybe you won't have to get to those cue cards on what crop yield potential is. And I also reference Van Ittersum. And can you imagine, as other graduate students in the room, if your paper was cited this many times as a MAC conference? I think this is the 3rd presentation in a row we're referencing this paper. So we talk about yield potential at its ceiling in a non-limited environment, but we know here on the prairies and most dryland agriculture, we are going to be defining yield potential based on rain-fed systems. So it's going to be limited by moisture, the precipitation that we get. So for this presentation, you'll see throughout, I'm going to refer to this as YP, yield potential. Our starting point, however, is what are we actually getting at the farm level? What are farmers harvesting? And so at the farm level, we are also limited by rain-fed or water, precipitation that we receive, and our soil's ability to hold that moisture. But we also are limited by our management decisions and our management practices. And so throughout this presentation, I will use YA to describe actual yields achieved at the farm level. So what does this look like for soybeans in Manitoba? To look at our starting point, here is the historic on-farm soybean yield from the past 26 years. Starting off with, let's see if I can get a pointer. I don't know if this pointer will work, but beginning in the 1998, our first record of soybeans, our early adopters were growing, I think, conventional varieties at that time, and we were happy with 25, 30 bushels per acre. Over the past 25 or so years, we've been gaining that half bushel per acre per year at the farm level, which is actually a little bit higher than what's reported in the literature, so we're making good strides at the farm level. Overall, we're looking at an average soybean yield over this time of about 32 bushels per acre, but our 10-year average is 37. And that's been really brought up in 3 out of the past 5 years, or 4 years, pardon me. We're looking at a 45 bushel per acre average. Now, I don't know if the 2025 yield is official yet, but we're going to be certainly above average. What is our potential? So there are different ways to define soybean yield potential in the literature, and Brian talked a little bit about this, whether it's simulation models. And there's going to be 2 ways that I've looked at this that I'm going to share with you today. The first one is by looking at small plot variety trials. So that's data that's accessible. We're choosing a uniform, highly productive area. We're managing pests, using best management practices. So this gives us a pretty good idea of what our yield potential is. So I have here still the on-farm yields, and now I'm going to bring up small plot yields. And what I did here is I took the average of what I would consider core sites of variety testing sites. So Dennis and MPSG, they test soybean varieties, and like the McVet committee does for all crops at probably a dozen sites across the province, but between 4 and 7 for soybeans were pretty consistently reported over the past 20 or so years. And so this is the average of those sites. And we can see here that historically we're achieving about 48 bushels per acre in our variety plots, a yield gain of about 0.4 bushels per acre, and the 10-year average is 51 bushels per acre. So that's a pretty reasonable estimate of what soybean yield potential might be here in Manitoba. Now, the difference between the yield potential and the actual yield is yield gap, which was introduced to us earlier. And in soybeans, it's looking like an estimate of that for us here in Manitoba is about 27%. Now, Brian had presented an average for Canadian soybeans earlier, and I was quickly converting that to bushels or looking at the other y-axis. And I think Brian had a 42 bushel farm average, which is higher, but that makes sense because that's Canadian-wide and that's going to be brought up by Ontario. And I think the yield gap that he had roughly estimated there was only about 19%. So it's looking like it's a little higher in Manitoba, which makes sense. We don't have the multi-decade experience growing and refining production practices for this crop. And in terms of yield gaps reported in other regions in the US, 22% is a pretty good average that's been reported for the Midwest. So here we have YP and YA for Manitoba soybean yield potential. And as Brian mentioned, it's not exactly realistic to completely close that 27% yield gap. What research is reporting is that we tend to plateau between 75 and 85% of yield potential. And so something that's realistic for us as agronomists and farmers to work towards is what's called the exploitable yield. And that's about 80% of yield potential. So it would be reasonable for us to aim for a provincial average of 41 bushels per acre here in Manitoba. And how do we do that? So this is where our role as agronomists and farmers and researchers come in by identifying what those yield reducing factors are at the farm level, regional level, investing in research, making sure that we have effective extension to communicate those results, and so on. And those main management factors I have listed here, and I'm going to go into a little bit more detail about some of those throughout the presentation, but this has been already mentioned: genetics, pests, cultural practices, fertility, crop nutrition. Field variability is also something I haven't seen reported in the literature, but that's another reason why we will not be able to achieve full yield potential, is because we are dealing with a very heterogeneous environment where we look at our yield maps, we have the technology to do that, and getting all parts of the field up to that yield potential is difficult. There's 2 things I want to show you with this graph. So I'm just going to bring up the 10-year average data again, and I think by the time we're finished this morning, everyone will be very familiar with these terms: yield potential, actual yields, yield gap. So repetition is never a problem. I mean, that's what I tell students anyway. So we have YA, YP, our yield gap, our exploitable yield. This is the 10-year average. But what we've seen, especially in soybeans, is what happens when that moisture deficit is reduced. So what does yield potential, do we close the gap? What happens to yield potential? Remember that yield potential is also limited by moisture. So yes, in years where moisture deficit is reduced, and I'll use 2022 as an example throughout this presentation, but 24, even 25, the tail end of our season, increased our precipitation. These are examples of years where we're seeing this effect. So our field average went up 45 bushels, but so did our yield potential, because it's also limited by moisture. So when we receive that moisture, yield potential goes up, and we still have that yield gap. So the yield potential of our variety plots in those years was over 60 bushels per acre. And when I talk to farmers, this is how I communicate. We talk about 60 bushel soybeans. How do we get there? Can we get there? The other way to look at estimating yield potential, other than small plot research trials, is to look at the top percentile of farmer fields. And when I do that, I get a very similar YP. So if we were to look at the top 15% of yields in 2022 is the year I did this for, it was 64 bushels per acre. Very similar to the yield potential when we look at small plots. So when I have farmers in the room and they sit back and they're like, yep, I was one of those farmers, 60 plus bushels per acre, I say, well, only in certain regions, and I say there's always work to do, because if I were to look at the top percentile of small plots, we can see 80 bushels per acre. I've even seen 90 at Carmen. So there's always work to do. Okay, since I've alluded to the fact that moisture is so important for crops, and it is for wheat and canola, but it's especially important for this long season crop that uses a lot of moisture. I'm going to show you how this has been correlated to yield in Manitoba. This is from Nate Ort's thesis, a graduate student of Dr. Yvonne Lawley's. And he related precipitation from planting to R8 to soybean yield and developed this highly correlated linear curve here, where we're seeing about 4 to 5 bushels per acre in a high yielding environment for every inch of precipitation. And about 12 to 14 inches of precip is what we need for maximum yield in soybeans. Brian also mentioned critical growth periods, and Nate also looked at this for different growth stage intervals. So in soybean, we're usually focusing on the R3 to R5 stage as that yield determining factor, but Nate found that it was actually the precipitation throughout the season that correlated best with yield in our region. Curiously, I also did this, and I'm going to bring in some of my own on-farm experiences. I related our soybean yield to precipitation on-farm, and I got a similar relationship. Okay, it was quite surprising, but it really supports what we know about soybean and crop water dependency. But at the farm level, we're only getting about 3 bushels per acre for every inch of precipitation. Bringing in some MAC posters, which are always awesome. This was a poster from a few years ago reminding us that it isn't just rainfall, but soil moisture that puts together that soil-water balance for crops. And I'm just pointing out here, and in comparison to other crops, so on average, we're facing about a 4-inch moisture deficit in soybean production, compared to wheat, which is only about a 1-inch, so less water use, less deficit. And we see this impact of moisture affect production acres. So whether it's a dry year or a wet year. So in 2013, that's when we saw 1 million acres, and we had steady increases after that, relatively stable yields. We hit 2 million acres in 2017, but then as soon as we hit dry cycles, we really have seen, especially the last 10 years, we've seen that seesaw, the teeter-totter effect. Low yields, acres go down. And so it's been a very consistent response following precipitation, yields, and what farmers are willing to put in, competing with canola most likely. So the last 2 years we've seen high yields, and I don't know what the projections are for next year, but I'm thinking we're going to be going up again based on experiences this past year. Okay, going back to 60 bushel soybean. So because who's here familiar with Yellowstone? So when I talk about 60 bushel soybeans with farmers, it just so happened that the Yellowstone series was happening during these very high soybean yield years. And so the characters of Yellowstone really go along with some of the observations that I've made. And so here I have John Dutton, and he's really interested in knowing where those 60 bushel soybeans are happening in Manitoba. So here I have, just like grades, yield is a normally distributed variable. And so here we have the data distribution of field averages in Manitoba. And on any given year, no, 60 bushel soybeans is not necessarily a realistic goal. In fact, less than 2% of fields in Manitoba are actually achieving 60 bushels. But in years like 2022, even 24 and 25 here, wow, take a look at that. With the 45 bushel provincial average, we are seeing almost 15% of soybean fields reach 60 bushels or higher.
That's not what the coffee shop says.
What coffee shop there could be some 80s. We're seeing some 80s there. So where in Manitoba are those 60 bushel soybeans happening? Well, you could probably guess. It's going to depend on precipitation, soil. So here we have just a reminder of the texture changes that we have, the Red River Valley, the clay soils, they're holding the most moisture. They're also getting the most precipitation. And so it follows that the long-term averages are lower in the southwest, and they get higher as we move into the Red River Valley. And if you apply that equation of 3 bushels per acre on-farm yields, it actually equates very well to what these long-term averages are, considering that the precipitation range is 10 to 14 inches in Manitoba in an average year. But where exactly are those 60 bushel soybeans? Well, they're right there in the Red River Valley. So the RM of Montcalm, Rhineland, Roland stood out last year. Roland had a 57 bushel per acre average last year. But when you look at the 5-year, 10-year averages, it's the Red River Valley. I'm looking at Brunel there. He's all too familiar with that. And that's where these big bushel soybeans are coming. And also just to point out that there's variability even within these areas. So there's soybean yields by soil productivity index from MASC. Okay, I gotta speed it up here. Here we go, Yellowstone character again. This is me in one of my soybean fields in 2022 when I really realized, wow, this I think could be 60 bushel yield potential. So this is just a picture to show what that looks like, and I'm gonna kind of walk through a little bit of, in the end, did Kristen reach 60 bushel soybeans is kind of the question I give to farmers when I talk about this. And Jimmy, like learning how to ride a horse, this is, okay, can we do this? So we've established that soybean yield's dependent on moisture, but we can close that yield gap or work towards that exploitable yield by identifying what those yield reducing factors are, genetics, management practices. So now I'm just gonna briefly highlight some of the work that I've done, some of the work of my colleagues over the past decade that we've really expanded our soybean research efforts. But the first one I'm gonna start with is genetics. Here is a piano graph of long-term average yield of 55 varieties that were tested this past year in the MPSG variety trials. And it's clear, there's like a 30% variation in soybean genetic potential there. So there's a yield gap in itself. Soybean seed and variety is highly competitive, and I tell farmers there's really no reason why you shouldn't be in the top percentile just right out of the gate, picking those high-yielding genetics. In terms of trait trends that I've noticed, so here we have a summary of the top 10 or 12 soybean varieties, and so we can see the shift in herbicide tolerance has happened. Compare this, so we have 75% R2X cultivars. Just 5 years ago, we were still 50% just Roundup Ready. Okay, so we've seen that shift, maybe a little late to the game if you ask our weed specialist. It's also the highest market share of a single variety, 21%. The decal variety there, it's easy to see why, high yielding Phytophthora resistance, SCN resistance, good IEDC score. Okay, the last time we saw high market share was, if you remember, the Y4 is from 5 years ago, might have hit like 15% market share. We're also seeing variability in these agronomic traits. Not all of our most common varieties have SCN resistance, have good IDC scores, and the major PRR genes that are being used are not effective against the races that are present in Manitoba fields. Do we need to be concerned about SCN? Yes. Ask Mario, yes. Here's just a reminder that survey efforts are ongoing. It is present, be it at very low levels, but it's likely in more fields than it's been tested in. And here's just a great video from Mario showing just a visual reminder of what those cysts look like at a vegetative soybean. So digging up those roots even before we're checking for nodulation to see if SCN is lurking. IDC score, I'm not going to talk much about this. We're very familiar with iron chlorosis in soybean and how choosing genetic low scores is very important. What I want to add that's new is that I've started looking, so in collaboration with Dennis, I've taken the IDC trials to yield to correlate the negative correlation between IDC score and yield. And I've also established an ID or a non-IDC site in the same field so that we can compare the yield potential in non-IDC conditions to IDC conditions. And the reason for this is because there's been areas of the US that have shown a potential yield drag between IDC score and yield. And so previously we've only had yield data from fields outside of the IDC site, so now we have yield from a non-IDC area in the same field. And the good news is I don't have that data available yet, but the early results are showing me that they're performing well across the field. So choosing a variety with a low IDC score is good for IDC areas and non-IDC areas. Phytophthora root rot, I already mentioned this, but this is just the survey data showing from 2000, I think it's 18-19, but similar results in speaking with MPSG from the 2023 survey, that the pathogen isolates that are in fields are overcome, the genes that we are using are overcome by these isolates. Most common genes that are being used are not effective. And that's actually increased in the 2023 survey compared to 2018-19. So put that in a different way, if we look at the genes that are being used in 80% of the market share varieties, and we compare that to what genes are actually effective, it's very little. What's being worked on now by MPSG in collaboration with Ontario is looking towards standardizing field tolerance testing. So yes, companies provide field tolerance ratings, which is the contribution of minor genes towards Phytophthora, but each company, it's not standardized. So a score from one company is different than the score from another company. And so what MPSG is working towards is testing those in Manitoba environments and providing standardized scores to farmers and agronomists. So this is something to look for in the coming years. Other cultural practices, here's soybean yield response to seeding window. In the US, planting date is very important for soybean yield potential. We are just not seeing that strong gain here in Manitoba with our cool soils, cool springs, and then the potential for frost, May 20th. So the data is pretty clear. This is from 11 site years. You may have seen this before. Seeding first, second, third week of May, there is not yield to be gained by going earlier. There can be in certain field by field, year by year scenarios, and that's where that decision-making tool comes in, where we think about soil temperature, risk profile, where we're at with other crops on the farm being seeded. But basically, if you're seeding in the first 3 weeks of May, you're getting the yield potential. Seed depth is something that I've looked at, and this has been in response to dry years and wet years. So planting deeper, farmers have done to get the moisture. I hate to say it, but some have broadcasted in those very wet years. And this is very clearly showing that seed depth is important for soybean. So aiming for 1 1/4 inch, anything outside of that 1 inch range, and we are seeing a 10 to 20% yield reduction with shallow and deep seeding. Without getting into the weeds, I'm just going to mention the weeds, and just to say that cultural practices that are good for soybean yield are also good for weed competitiveness. So an early to mid planting date, not too early to give the weeds an advantage over the soybean, narrow rows, plant densities, fall rye cover crops, vigilant scouting, and weed identification. We know kochia and water hemp are here, and we are, this is going to be a major limiting factor going forward. It already is. And there's been a lot of data on this by other researchers that I have mentioned here that supports this information. Okay, coming back to Kristen soybeans. So here we are, late August.
The kids are gone.
Yes, sometimes I can scout without the kids. Yeah. Here we are, pod counts, like 47 pods per plant, like anything over 30, and you know that you're looking at a good soybean yield potential. 4 bean pods, bottom to top. But what's happening here in late September, and you see what's happening over the canopy there? White mold is setting in. So I'm going to bring in my last Yellowstone character, and now I'm not so convinced that I'm going to get 60 bushel soybeans. So what's happening? So in my field, I'm identifying white mold as a yield limiting factor. So I took some counts, and it was 15% incidence across the field, which is equal to a 3 to 5 bushel yield loss. And very good data from Michael Wunsch. He's actually here tomorrow, so maybe I can learn more about how to precisely time maybe a fungicide application to manage that, but that was definitely a yield robber. If I talk the root rot, here's a patch. I probably had 2 or 3 acres in this field that was just robbed by excess moisture in phytophthora root rot. Should I have done a fungicide application? Another very valuable source of information has been the MPSG on-farm network. Here are the results of fungicide trials over the past 11 years. Less than 20% return or probability of a yield increase. So when I look at this data, that was one of the deciding factors that maybe not do a fungicide application in that field. Would I have done things differently? Maybe, but I also had like 2, 3 kids running around, and life happens when you're scouting. You know this as agronomists and farmers. It's also helpful to know what isn't going to increase our soybean yields here in Manitoba. Here's Dr. Yvonne Lawley's data on the application of N fertilizer. She looked at this across a range of rates at 3 years at Carmen and found no statistical differences. So we just need to rely on a good inoculation strategy, let soybeans fix 70% of their N. And in terms of, okay, but what about the data from the US? Even in the US, they've really only found an N gap, if I'll use that term again, when you reach yield potential of 70 bushels per acre plus. So that's what I found from the US. And even when they looked at those studies, it was only a very small proportion of the variation in soybean yield that contributed to, which is a segue into one of my last slides here. Here is a variance component analysis from some of the agronomy studies that I've done. So what it's showing is what of the studied factors are accounting for the variability in soybean yield. And you can see here, just re-emphasizing the importance of environment. And this is not unlike wheat or canola, but to use as an example, Don Flayton and Amy Mongen looked at this with their N high-yielding nitrogen rate studies. And so in a crop like wheat or canola, I would expect at least 10, maybe 20% of that variation to be explained by nitrogen fertilizer. But when we don't have that for our legume crop, a long season legume crop with high moisture, the effective environment is going to be even more significant. And so environment is our big hammer, but we can't forget about these little hammers if I'm going to bring in an analogy from our integrated weed management talks. And I would be amiss not to mention managing soil, because it is about what's available to the roots. And so yes, we want to have good precipitation, but we also want to be able to have that soil hold that moisture. So practices reduce tillage, cover crops, practices aimed at increasing organic matter, getting that water infiltrating, keeping the soil in the field, reducing compaction are all things that are going to benefit soybean yield. All right, to summarize, what have we learned about soybean yield potential? So we have 51 bushel per acre potential. We've seen this increase to over 60 bushels when that moisture deficit is reduced. At the farm level, we're still looking at about a 37 bushel per acre average, but we can reasonably expect to reach over 40, I think, in the short term. And that's where we come in again as farmers, agronomists, and researchers by identifying these yield-reducing factors, which I've kind of summarized there. Herbicide-resistant weeds is probably one of the number one, and these are all going to be specific to farms and regions, but those are probably some of the most important ones that I've identified and observed through the years. So this is on a provincial level. Something I want to leave you with as agronomists and farmers is to look at this with the growers in your area. So I'm going to come back to my farm level case study with MacMillan soybeans. We're in the Interlake, and when I look at yield potential for the variety sites that are near my farm, or if I look at the top percentile of yields in my risk area, it shows me that my yield potential long-term is 45. In years where moisture deficit, it says 60. And so here's my production practices. I've mentioned what I think were yield limiting factors in that year and things that I can improve upon. So you can probably tell by the look on my daughter's face whether or not we reached 60 bushels per acre. She was pretty disappointed. We only got 54 bushels per acre. But we're not in the Red River Valley, and I have to remind her we're in the Interlake. We're still kind of in cattle country. But we're still pretty happy with that and our long-term average. We are past, we're over the RM average long-term. And then another way to kind of visualize this is, if we were to do this on a grower or regional level, is to kind of pinpoint where your yield gap is relative to others. So if the average yield gap in Manitoba is 27%, but if I'm past my exploitable yield on my farm, but I'm actually closing that yield gap down to about 10 to 17%. So on a report card, that's looking pretty good. And with that, okay, I think I just got the 2-minute mark, but thank you for your attention, and I would take any questions. I don't have anything to give away, but maybe this memorabilia is worth something.
Thanks, Kristen. There are a bunch of online questions, so maybe start with one of those, and I'll see if there's any in the room.
You bet. What is the difference within field variability in soybean production between the Red River Valley and Western Manitoba above the escarpment?
Okay, that's a great question. I'm going to go back to, so there maybe, is that within field variability or within region variability? And the answer to that might be, there might be a different answer to that. So when I think of the Red River Valley, and maybe Brunel's going to talk about this, I do think that we might have more uniformity. Not to say that there isn't variability in fields in the Red River Valley, but compared to topography, texture changes, sloughs in the Southwest, I would say field variability might be higher in the Southwest compared to the Red River Valley. And I think that's also probably evidenced by the SPI differences between the soil classes. There is a little more uniformity coming from the Red River Valley.
Anyone in the room? Oh, yeah, okay.
Yeah, I was wondering, have you been able to compile much data on, I saw you had the rainfall slide there. Have you been able to get data on how timing of rainfall and maybe temperature as well affects yield?
I haven't. This is that kind of deeper plant physiology interactions with environment that would be great for Manitoba. I know Nate did look at, like I mentioned, the different growth stage intervals and precipitation. But no, we haven't. I'm trying to think if we've taken it past that. Even incorporating not just precipitation, but soil moisture so that it's a true water budget and not just precipitation. So no, we haven't looked at that, but I think that is a priority for us to look at in Manitoba.
Thank you. Oh, wait. Oh, thank you. There's this, and a little dip. Thank you.
Thanks again.